Hey guys, welcome to the shop. This week we're working on the heart of the dual saw, and that's the gearbox. At least as far as I'm concerned, the most important part on the whole unit. The deciding factor whether this project moves forward or stops. And we tear into it almost completely. Tear it almost completely down. And I think that you'll find that its design is pretty interesting. I know that I did. And I'm surprised at how heavy duty this thing is. Like you would expect a big saw like that to be. But nonetheless, it's neat to see. And its condition is, you'll see. I'll let you be the judge. Is it good or bad? Anyway, thanks for watching, guys. Not a lot of machining in this video, but there's a lot to come. I can guarantee you that. So, thanks for watching. Let's get started. So I'm trying to get this pulley off here. I want to inspect the shaft and see what kind of condition it's in. It looks like it's been welded on the end. I don't know. That's not promising. It's supposed to have 2 set screws in it. I believe it's only got 1. So let's see if we can get this off here without stripping out this set screw. Wow, that's in horrible condition. I'm surprised that came out at all. Feels like the end play, not a whole lot, which is nice, but listen to the sound. I believe it's got a rough bearing somewhere. But, overall the shaft doesn't look absolutely horrible. It's been chewed up. So here's the main pulley, or the main drive wheel. It's definitely got a rough bearing in there somewhere. I want to get this wheel off here if I can. If this is where it comes off, and have a look. Let's see what the deal is. I think this is just a cover. Oh, look at that. Snap rings off. Huh. Somebody's been in there before. Wow, that's got another gear inside of this. Now, let me get you another angle of that. So check out that. That's a cast iron gear. And I don't know why that snap ring was just laying in there. But that holds the wheel on. Somebody's definitely been in here before. But this is actually a gear. Let me get it off there. There we go. Huh. Wow, that'd be expensive to make, but it's got grease on it. I have to go over that and look at it real good. Huh. Then there's the output from the gearbox. Wow, that's pretty cool. Let's see what's behind door number 1 with the mix match screws. It's only got 2 in it and they're both different. It's not very confidence instilling. Somebody did grease this gear. I guess that's alright. Somebody put some sealing goo on there. It's the gear drive, the ring and pinion. It's, I guess, an inspection port. Oh, that's good. Wow, man, that's fine thread. Somebody's definitely been in there before, because I can tell you, that's not supposed to be there. Alright, so this main output feels really good, but in here, where that main shaft goes in, if you look at the play in that inner race of that bearing, it's not supposed to be like that. So we'll have to pull that bearing out. You know, I don't mind replacing bearings. It's not a big deal. Everything else looks serviceable here, so I'm gonna have to pull that out of there, get some numbers off of it. Oh man, that won't come out with that in there. What? Yeah, it will. And you talk about an expensive piece. Cast iron, all cast iron, internal bevel gear. Man, if this was bad, you could guarantee that saw would be complete garbage. But so far it looks fairly promising. You know, it's got a little wear in it, but nothing that, you know, wouldn't last another lifetime. So I'm just cleaning out the metal chips that got ground in here with a little wire brush. Man, these things are just unreal handy for this kind of work. I wear them out pretty quick. This was sent to me by Tom Fleming. He sent me several. He sent me a needle file set, some end mills. So thank you, Tom. I appreciate it. I mean, these are a trick for this kind of stuff. Let me show you what's going on here. Alright, so there's the bearing seat. You can see somebody's built it up with weld. Actually, now that I've got it off, it didn't seem like it was extremely tight. I'll have to check that bearing journal for size, but now that I've got it off, it doesn't look as bad. Somebody actually done a pretty decent job on that. You know, all I could see was that on the edge of the outside edge of the bearing, and I was expecting you know, a bunch of voids in here and it'd be really crappy, but surprisingly it's not that bad, so maybe that's serviceable. But check out that spot where that set screw is supposed to seat. So it's definitely got issues, but it may be serviceable. We'll see. I gotta get some bearing numbers. Let's get a look at the front wheel on this thing. It does have a little play in it. Doesn't seem bad, but you know, while I'm messing with them, I might as well, you know, inspect it also. This is going to have to be painted. It'll have to be taken off to repair the damage behind this wheel where the blades have come off before. We'll get a look at that in just a second. Let's see if we can get this thing off here. About that, or if that's probably supposed to have a snap ring on it. But I don't know that for sure. But looks like ladybugs seem to like it. Let's get this off and check it out. Alright, so that's definitely not factory. Just a brass threaded collar that somebody put a set screw in. And then they ground down on the shaft for some reason. Wow, is there anything on this saw that hasn't been rigged? I'm sure it had a snap ring in it at one time. Oh. Alright, so this big back bearing on the front wheel here has a, slid out of the pulley, has a snap ring groove in it, and they were running it without that snap ring. And you can see this wear that's caused here. I mean, it hadn't hurt anything really. You know, it's kind of ugly, but you know, no real damage was done. But what that snap ring on that's supposed to do is hold this wheel. You know, this goes into the back of the wheel here. And the wheel's supposed to sit against that snap ring, and it controls the depth that this wheel sits against the frame. And I'm sure you can see this damage around through here, that some of these tracking issues I'm sure they had is just due to because it was put together wrong. You know, so at least that's what I believe. I mean, that makes sense to me, that would have a snap ring on it that would set the spacing of this pulley, you know, off of the actual saw a little bit more, keep it from rubbing. There you go, more issues. Tapered roller bearings down there. They actually feel pretty good, really. So a lot of saws of this vintage are cast on the frame, or at least a lot of them that I've seen. You know, the Kalamazoos and stuff like that. This one is a weldment, so it's 1/2-inch plate. It's got 3/8 tube or channel with capped ends, just to give the body of the saw some rigidity. It's really a fairly simple construction. You know, of course the base is cast, the blade guides are cast, and then the gearbox and the tracking wheel is cast. Thin sheet metal top, piano hinge that runs down the whole length. That'll have to be replaced. It's kind of crusty. And then some body work on the lid and a clean and paint. It's about stripped down, really. Hopefully there's not much more we can find wrong with it. But, you know, we'll see. Alright, so our main drive pulley's all cleaned up. just like everything else, it looks like it's had some work done on it. It's got a bronze bushing in it that's been locked in with a couple set screws. Whoever done this done a decent job on it, but I believe they reused an old bushing off something else. Either that or, you know, who knows. It's got a partial keyway in it, so that makes me think for sure that it's not a factory job. But the fit on this shaft is really not that bad. You know, it's not tight by any means, but I don't know. You know, unless I rebush that, you know, it's going to ride like it is. I mean, it's easy enough to access on the saw anyway, so if it gives me trouble, I can pull it off and redo it. So this is the nut that holds our little bevel gear on here, on the shaft, that drives the gearbox. I want to knock those burrs off the back of this and just give it a grind. So I'm going to throw it on the grinder real quick and just dust off where it's been beat to pieces. I already stoned this side, so I'm going to knock that off real quick. Then we'll look at the rest of the stuff. So this right here is a 3 horsepower Arco Roto phase. It's the original phase converter that I started with. I got this with in a package deal with the Bridgeport style mill that I had. And I also powered here recently the surface grinder with it also. So anytime I wanted to use either 2 of those machines, I had to go to the wall, plug in this rotary phase converter, you know, separate from the other American rotary phase converter that I had to power the K&T or the shaper. So I eliminated this one this past weekend, wired in the surface grinder and the Bridgeport mill. Everything that I have now is wired into the new 20 horsepower American rotary phase converter that I got outside. And I tell you, that's nice to not have to go through the extra steps of plugging in another one. I mean, I know it's small, but when you do it 5 times a day, you know, it gets a little aggravating having to go from one phase converter to the other. So I was glad to eliminate this one. It's going to go in the attic for storage in case I have any issues, because I had to send the old 10 horsepower American rotary phase converter that I'd been using back to American rotary. So, you know, this was a nice unit, good and reliable, but it was noisy, and I'll have to say that I'm glad to retire it. Man, having a surface grinder, even if it's not, you know, in the best condition, is such a benefit for the shop. So that's it. Just wanted to dust that part off. So there's the gear that comes out of the gearbox and powers this big drive wheel. As you can imagine, a lot of swarf from the sawing process gets in here. It had a lot of you know, metal chips in here packed, so it's got some wear on it for sure. Let me get you in there a little closer. You can see, pretty substantial, but you know, that'll last forever as is. But here you go. So, you know, same here, got some wear in it, but you know, nothing that's gonna cause this thing not to work for years to come. So here's the gear that's powered by the big drive pulley here. The main input. It runs inside the gearbox. It's definitely got some wear on it too. Now I've started cleaning it up. It has some rolled over edges. Let's see if I can find some for you. I wonder if I can get you a little closer. There you go. See those little rolled up burrs? Now I've been stoning those off. You can see I've got, you know, partially cleaned up, but you know, that's same scenario as the main drive gear here. This will run forever as long as it's kept clean and good oil in it. But it definitely got some uneven wear on it from that bearing going bad. So now that I'm pretty confident that at least the gearbox of that saw is in, serviceable condition. Yeah, I can use it. I want to continue moving forward on the pulleys, or this, variable speed drive unit of that saw. So I've got a couple options here that I want to talk about really quick, or at least as quick as possible. Regarding this repair and the path that I want to take to get it back in as good a shape as I can, with as little money as possible. Now, both of our pulleys here that ride on this center hub, there's actually three. You got a center section and then the two outer pieces. These are both really bad worn, and if you watched the video that I done last week, we brazed up the keyway that was in this one that had a crack in it. So one way or another, these two sections are going to need either bored and sleeved, or just bored out for an oversized, center hub. So that's an option that I'm definitely exploring. A buddy of mine, I'll show you when I get it, was sending me a piece of 3-inch. This original hub is 2 3/4. So we've got some room to go oversize on this without hurting anything, and then cutting new keyways, which I think is probably my best option. Now this has bronze bushings in it. It has an 1.5-inch bore in it. And the bushings in this are actually serviceable. As far as I'm concerned, they are. It runs in grease, and it's perfectly usable. But the outside of this thing is really clapped out. Both of the keyways are damaged in it. The snap ring grooves are damaged. It was ran without keys. Those snap ring grooves ran around in those snap rings ran around in their grooves a bunch and just wallowed them out. And it's got some rust pitting on it. Just not a good candidate to reuse. Now, I had a lot of people reach out to me in the last couple weeks, offering me pieces and parts to help with this repair. Because when I'm done with this saw, it's still not going to have any real value, but it'll have some value to the shop. And I don't want to invest as much as it would really take. I mean, you're talking several $100s to fix up this unit properly. So I'm glad I won't have to do that through the help of the viewers. So these people are people who've helped me in the past, and I really appreciate it. Peter Ramos sent me a piece of Aquamet 22, which is some great stuff. It's marine shafting. It's really corrosion resistant. It's good straight materials from the factory, and machines really well. And then Tom Fleming, which I'm doing some work for, he's a super nice guy who helps a lot of the YouTube guys out. He sent me a piece of oversized shafting in case I want to line bore this whole unit and go oversized, which I have not decided on yet for sure what I'm going to do either way. But this is a piece of 1144, which is really good to work also. The original shafting that went through this hub is completely worn and has to be replaced. So we need to make a new one, bore it out for the oil or for the grease holes, put some flats on it, drill and tap the end for a grease fitting, the whole deal. But one way or another, these pulleys and the center hub potentially will have to be bored. These will either get bored and sleeved or just bored to fit the new hub. This one has to be bored because, like I said, we were brazed up the keyway. Now it's got that big weld bead in there, and that has to be removed. So I'm curious to see what it's going to take to at least get a good true bore in both of these, or at least in one for now. I'm running out of time this week, but I'm just not happy with the fit. Between the wear and the pulley and the wear on the outside of this hub, just unacceptable as far as I'm concerned. So we'll probably make a complete new one. Oh, and a couple stickers that were sent into the channel, Maddie's Workshop and Craig's Workshop. I really appreciate those guys. They're really, super nice guys. So go check out their channel, and I'm going to be putting these up on the wall. So let's go over to the lathe, and let's at least try to clean this bore up and see what its final dimension is. At least cleaned up. I don't know that I'll stop there, but at least give me an idea of how big I'm going to have to go on this center hub. Alright, so on our pulley, I'm dialed in as close as I can get it using this outside edge. You can see we're basically on 0 there. Then we shoot up to around 5 thou, but we got a damaged area here. I think somebody's beat on it some, but then it goes back down to 0 and stays right around there for the majority of the way around. So I'm going to call that 0 because that's probably is 0, considering this is damaged on the outside. Now let me show you the face of the pulley and how much run out we've got here, and then we'll hit the inside of this bore with the boring bar. So hopefully you can see that dial indicator pretty well. This is a Tech-Lock, Japanese made. They're one of my favorites. I've got several of these. I scoop them up any chance I get. The spring's just real light in them, and they're really smooth. That's my experience anyway. And you can see we're hovering around -2 to 0 there, and it bounces. It's irregular. So that is 0, at least as close as I can get it to 0. So I'm going to call that good enough. So let's use this little carbide bar and clean this bore up a bit. I think that's going to be plenty good enough for what we're doing. So I tried to get as much of that brazing flux off there as I could. Man, that stuff basically glass. It's hard on a cutter. However, just using this little carbide bar, it should do alright. That actually cleaned up really nice. So check out that bearing stack up that come out of that drive wheel. It's the same on the idler wheel also. 2 double row ball bearings, pretty substantial in size. What you would expect to see in maybe a small passenger car or something. So they definitely did not under-engineer them, that's for sure. But these are clapped, so got some new ones on the way. New bearings for this shaft are also on the way. This is the main input shaft that runs this bevel gear. And I'm just putting in it what I got out, which were 2 standard roller bearings. But the more I think about it, the more I question whether these were not supposed to be, or these were supposed to be angular contacts instead of standard rollers, because of the fine adjustment on the end here and the load that this bevel gear would place on that. I'm questioning whether somebody put the wrong bearings in it or not. I just don't know. I don't have a parts breakdown or even a serial number on this saw. It's just completely gone. So, bore cleaned up really well in this pulley. Did not take much at all to clean it up. I'm definitely happy with the repair. So, my ideas on this repair are kind of evolving as I go, even within this video. I originally was going to reuse these, or at least that was an idea, but they're just so chewed up on the inside, and I'm making a new outer hub anyway. I just decided to, do the jazz hands and see if I could find some good, bronze bushing material, and I ended up finding a piece of 2 3/4 inch solid by 3 foot long aluminum bronze C954, which is some really good stuff for such a good price shipped that I question, if it'll ever even arrive or not. I don't know. We'll see. But I think my best bet is just to go oversized with this slightly, new bush, keys, all that good stuff, and I think I'll have a good tight unit when I'm done if I do all that. But made a new keyed washer, just hand filed that out. If you've done that before, you know how fun that is to file a keyway in a washer. But had to do away with the star washer that they put in there because that would have never worked. You get the idea. We're starting to crest the hill and start going towards the back together way, which is, you know, exciting. Got to get paint and all that good stuff, but you know, and a heck of a lot of machining to come. But you know, that's where I'm at so far, and pretty happy, I guess, with the condition of everything. At least it's usable. So in this cabinet here is all the original controls for that big do-all saw. And most of the stuff in here is complete garbage, and outdated also. But it does have a nice motor starter in here that I could potentially use. That, you know, I want to get it out of this cabinet that's got water in it and stuff, and get it in the shop where it's dry. So let's see if we can't, you know, strip this thing out, and I'll give you a good look at what all is in here. So I'm guessing all this stuff is, you know, from the 70s probably. It's old, that's for sure. But, you know, that doesn't make the starter bad. If we can get it out of here. So I'm not for sure what the voltage on the coil is on this thing, but I want to get it out of here, see if, you know, how good it looks, see if the contacts look any good on it, and, you know, because potentially I may use it. There we go, that's a Westinghouse motor starter. So there's a closer look at our electric motor starter that we jerked out of that cabinet. It's a Westinghouse Lifeline. Looks like it'll run a 7.5 horsepower motor on 220, which is more than what we need. There's your 3 power lines in, red, black, and white. And then your 3 lines out. All this does is take a control voltage, a small voltage that you can, you know, activate with a small switch. It energizes an electromagnet or a coil in here that becomes a magnet and either makes or breaks the connection through here. So that's pretty much it. Got 2 fused links, and you know, it's pretty simple, really. It's the same basic thing as what I put into the K&T. These fuses are also resettable, but you know, a little different design than what I put in the K&T, but does exactly the same thing. Alright, so I think that's it, you know. And I'm not disappointed with this condition, even though I wish it was a little better, but to be honest, it's in good enough shape to last me the rest of my life, I think. With minimum, you know, maintenance and care, this thing will run for my needs forever, and probably a lot of you guys too. You know, saw like this was made to last a lifetime and make money. So I'm sure this thing pulled its weight, at least as far as the wear on it shows it did. And you know, I think a lot of the damage that this thing has is from a lot of repairs. You know, people on the job site, you know, like boss says fix the saw, we need it to run no matter what, just make it cut. And that's what was done, I'm sure. So, you know, a lot of equipment I've seen is in bad condition because of that. That's just the way it is. So we got to try to fix it. I think we can, and I think it's going to be worth it in the end. So a lot of parts on the way, and it'll be nice to get this thing going back together instead of coming apart all the time, starting to look like a skeleton. So that's it. Thanks for watching, guys. Thanks for all the comments and suggestions. I've used a lot of them. And need anything, send me an email. If you haven't subscribed to the channel, do that. Click on my little guy up here. That's it. So thanks for watching, guys. I can't wait to get this thing painted and all pretty. So that's it. Thanks for watching, guys, and I'll see you next time.